Dear children, we have learnt the first part of Unit 2 Geographic Grid, Latitude and Longitudes. Already in the last class we have learnt about latitude. Today let us learn about the longitude. Longitude. What is a longitude? A longitude is the angular distance of a place east or west of the prime meridian. The prime meridian is the line of longitude whose angular distance is defined as 0 degree. It passes through Greenwich near London, and this prime meridian divides the earth into two hemispheres, that is eastern hemisphere and western hemisphere. The lines to the west of Greenwich are suffixed with W, and those east of Greenwich are suffixed with E. For example, 60 degree west and 60 degree east. There are a total number of 360 lines at 1 degree interval. The lines of longitude are also called meridians of longitude. Meridian is derived from the Latin word meridianum, meaning noon. The sun crosses a meridian at noon. All places on a particular meridian will have noon at the same time. The prime meridian is numbered as 0 degree. The others are numbered between 0 degree to 180 degree east or west. The line 180 degree east and west refer to the same meridian. It is diametrically opposite to the 0 degree longitude. Thus, 0 degree and 180 degree meridian together make a full circle round the earth. Proceeding at 1 degree interval from both east and west, other full circles will be 1 degree and 179 degree, 2 degree and 178 degree, and 60 degree and 120 degree, and so on. Of the two lines in any segment, one will be in the east and the other in the west. The sum total of the two lines will always be 180 degree. Individually, all lines of longitude are semicircles. The two diametrically opposite lines make a full circle known as the great circle because these pass through the center of the earth or the circle. The distance between two lines of longitude is maximum at the equator, that is 111 kilometers. The distance decreases gradually as one moves towards the poles. It is because all meridians of longitude converge at the pole and are thus of equal length. The next topic is longitude and time. The lines of longitude, as stated earlier, are also known as the meridians. At a particular moment of time, if it is 12 noon at a given longitude, it must be 12 noon at all points on this longitude. The earth makes a complete circle on its axis. It covers 360 degree longitudes in 24 hours. That is to say, it covers every 15 degree longitude in 1 hour or in 1 hour. Then what is the time taken by the earth to cover 1 degree longitude? For 15 degree longitudes it takes 1 hour, it means 60 minutes. Then for 1 degree, what is the time taken by the earth? Let's divide it. 60 minutes divided by 15 degree longitudes, and the answer is 4 minutes. It means 1 degree longitude is equal to 4 minutes. Thus, if it is 12 noon at 0 degree longitude, it must 4 minutes past 12 noon onward towards the east at the next 1 degree east longitude, or at 15 degree east longitude it must be 1 p.m. Towards the west, it will be 1 hour less because the earth rotates from west to east as the sun first rises in the east. For the purpose of memorizing, EGA and WLS formula is used. EGA stands for East Gain Add and WLS means West Lose Subtract. This, in other words, means that for each 1 degree longitude towards the east, 4 minutes are to be added, and each 1 degree longitude towards the west, 4 minutes are to be subtracted. Eastern and Western Hemisphere. The prime meridian, together with the 180 degree longitude, usually divides the earth into the eastern hemisphere and western hemisphere. This division holds good practically for all purposes. However, any two diametrically opposite lines can also divide the earth into two equal hemispheres. Local time. The local time of any place is obtained by the overhead sun at noon. For each degree of longitude, the local time varies by 4 minutes. This let us see through an example. The question is, the longitude of Mumbai is 73 degree east and New Delhi is 77 degree east. If it is 12 noon at Mumbai, what is the time at New Delhi at the same time? Let us see the answer. So there are two lines marked. One is 73 degree east, that is Mumbai, and its time is 12 p.m. And New Delhi is ahead of Mumbai, to the east of Mumbai, and 77 degree east, and its time is unknown. Let us find out the time of New Delhi. First, let us find out the longitudinal difference between Mumbai and New Delhi. So, the longitude of New Delhi is 77 and minus 73, that is the longitude of Mumbai, and the difference between the two longitudes is 4 longitudes. Then let us convert this the difference into time. Let us find out the time difference between the two longitudes. That is, so we have got already the difference of longitude is 4, and multiply those 4 longitudes with 4. That is 4 stands for the time covered for 1 degree longitude, and 4 into 4 is 16 minutes. As New Delhi is to the east of Mumbai, the time difference has to be added to the time of Mumbai. It's already formula is given, east gain add. So that means the time difference which we have got has to be added to the time given to Mumbai. Therefore, the time at New Delhi is equal to 12 plus 16. It means 12 hours 16 minutes. 12:16 p.m. Time zones and standard time. Time zones. To overcome the confusion while allowing the interplay of natural forces to operate, the earth has been divided into 24 time zones according to the number of hours in a day. Each zone covers 15 degree longitude, that is 360 divided by 24 hours, and we get 15-degree longitude. That means within 1 hour, 15-degree longitudes are covered by the Earth. The time for the whole zone is determined on the basis of the central meridian of that place, while countries with a smaller east-west extent like India have only one standard time zone. Countries like Russia, Canada, USA have more than one time zone. What is standard time? The uniform time based on a central meridian is known as the standard time. For example, the standard meridian of India is 82.5 degree east. The time at this meridian is considered to be the time for whole of India. This is done in order to avoid the confusion of following the local timing from place to place. Greenwich Mean Time. Further, while fixing the time zones, the time at Greenwich at 0 degree longitude has been selected as the mean time. Thus, if it is 12 noon at Greenwich at 15 degree east longitude, the time will be 1 p.m. and at 30 degree east longitude, the time will be 2 p.m. Then what is the definition of Greenwich Mean Time? The time fixed with reference to Greenwich is called the Greenwich Mean Time or GMT. Indian Standard Time. In our country, 82.5 degree or 82 degree 30 minutes east is the central meridian. It passes through a place near Allahabad. It is known as the standard meridian of India. While fixing the Indian Standard Time with respect to the Greenwich Mean Time, we have to add 82 degree 30 minutes into 4 minutes and we get the answer 330 minutes. When convert those minutes into hours, we get 5 hours 30 minutes. This means that India is 5 hours 30 minutes ahead of GMT. Thus, if it is 9 a.m. at London, it must be 2:30 p.m. in India. So, if you add 9 plus 5 hours 30 minutes, so we get the answer 14 hours 30 minutes. It means 2:30 p.m. in India. International Dateline. The line of longitude 180 degree is one and the same for east and west of the prime meridian. Since it is diametrically opposite to the Greenwich meridian, it causes a time difference of a full day on crossing the line. The time difference works out to 12 hours from either side. Thus, on crossing the line, a day is gained or lost. The international date line is the 180 degree line. When crossing this date line from the west to east, a day is deducted or the time is fixed backward by 1 day. When crossing the ideal from east to west, a day is added or the calendar is fixed 1 day ahead. Dear children, about the international date line, I will explain to you in the classroom clearly. To avoid the confusion of having different dates within the same country, the date line bends and goes zigzag at Bering Strait, between Siberia and Alaska, and at Fiji Tonga, New Zealand, and some other islands. The next point is great circles. Dear children, before I begin the explanation for great circles, I would like to ask you to go through the worked out example to locate the places on the map or globe. Please go through those worked out examples and try to locate the places on the globe or the maps. Let us move on. Great circles. What is a great circle? A great circle is a circle that is drawn on the surface of a sphere, such as the earth, that has a radius equal to the radius of the sphere, and whose center is also the sphere's center. The equator is the only latitude that is a great circle, and all longitudes are a part of a great circle. Circles which do not pass through the center of the earth are small circles. All circles parallels of latitudes other than the equator are small circles. So all longitudes are also called a part of the great circle because longitude pass through the center of the earth. So they are also a part of the great circle. Whereas except the equator, other latitudes, they are not at all great circles, whereas they are small circles. Arcs of great circles are the shortest routes between the 2 points on a sphere. Uses of great circle. A great circle is a theoretical circle formed by the intersection of the earth's surface and an imaginary plane that passes through the center of the earth and divides it into two equal parts. Secondly, the great circles must pass through or touch the center of the earth. Infinite number of circles that touch the two opposite ends of the sphere can be drawn on a sphere. Intersecting great circles always bisect each other. In respect of characteristics, first one above, the equator is the largest possible circle among lines of latitude. The equator and all diametrically opposite longitude touch the center of a circle, and therefore they are known as the great circles. Characteristics 3 excludes all latitudes except the equator. All the parallel latitudes are called small circles because they do not pass through the center of the earth. Uses of great circles. Navigators use great circles to find the shortest distance between any 2 points on the earth's surface. A great circle route is the shortest distance between two places on the earth and lies on the arc of a great circle. Using this hypothesis, the shortest route from New York to Moscow would be over the North Pole. Thus, it does not take into account restrictions such as weather or political restrictions imposed by the countries concerned. It also does not take into account lack of landing and takeoff facilities for airplanes. Second use, great circle routes are specially important for places that are on opposite sides of the globe. Most globes show great circle routes between distant ports across the Atlantic, the Pacific, and the Indian Ocean. The third use, great circles are used by meteorologists to determine climate and weather conditions in a region.